And if you found the Zoom videos, I'm going to click on modules. Wait, let me make sure I'm in student view so that it looks the same. As we notice, there's a big difference. So if I go to modules, up here at the top, the Zoom class session playlist, our 120 class is this YouTube playlist down here. So after our class is done each day, when I close the Zoom session, it creates a recording. So it can be really poor quality, because like when I'm standing over here, the mic isn't hearing me. That's okay. So because as we go through the semester, most of what you're going to be wanting to get out of these Zoom sessions is coding practice and some of the programs we write and things like that. So the Zoom sessions will be much more valuable then. But that's where they are. You can find them. Try to load every video to that same playlist so they're all together. So we're in week 3. I'm going to go look at our modules. Last week we were talking about binary, and you guys were creating an awesome Scratch game. We're going to look at everybody's Scratch games next time. I want to today because they're still not due yet. I'm going to give everybody until midnight to get those things fine-tuned if they want. You guys don't forget to be looking at the discussion and looking at everybody's Scratch games and giving them feedback if you notice a bug or something that you really like about it. And then we'll look at some of them on Thursday. We'll try to look at all of them because it's usually pretty neat to see everybody's different ideas, depending on our time. So don't forget also to make sure that you went upstairs and signed that Find Instructor's Office sheet. I think most everybody got that, but there might be a name or two missing. That's some super easy points. Gosh, it hurts me when as an instructor I have to put a 0 in assignments like that are just so easy, because we're going to be doing some stuff that isn't quite so easy. So get those easy points while you can. So that one out of the way. Now, we also have a quiz that's due tonight. This is just a really quick binary to decimal conversion. You're going to do this one on your own, so get it done outside of class. Remember, whenever you're working on a binary to decimal conversion, I wanted you to know how to do that so that if you were ever taking a certification exam, you would know how and you wouldn't have to worry about failing that question, because they do pop up. But if you're taking a certification exam, you're not going to be able to use a calculator. So remember that on your own, that if you do that quiz and use a calculator, it's up to you, but you won't have that option if you are ever in a situation where you really need to do that conversion. So if you can push yourself and do it without that aid, that would be better. Remember, it's just 1 and 2 digit numbers. So we're not working with great big numbers. So I want to click on the week 2 summary, and Mark is done because I hadn't done that yet. And I want to be able to get to that week 3 stuff. So now I should have everything in my week 2 module completed. I'm going to hide it so that it's not in my way anymore. So with week 3, we're going to look at developing a program, some of the preliminary steps. How do we get started? How do we make sure that we know what's needed and what's wanted? How do we make a plan? You know, if you're working on your own, it's just you, then not having a plan is really no big deal, right? Because you can go around in circles and in circles and in circles and eventually get someplace, and that'll be okay. But if you're working with a team, you need to have a little bit better of a plan so that you can send everybody off with specific tasks that they need to perform, and you can all work together to get things done. So we want to be able to develop a plan for developing software. So that's what we'll be looking at this week. While we're doing it, if you notice some assignments that we have, let's look at them because I don't want you guys to get worried about them. First of all, a lot of the stuff in this week, if you notice, is info. How to get Microsoft free software, how to get Office for free, how to get the Raptor flowcharting software that we'll be using a little bit in our class. And then finally, some assignments. The only assignment that's really on your own are the Chapter 3 review questions. These other 2, if you notice, are marked lab. That means that we're going to do these in class during our lab time. You'll work with a partner. So you do not need to worry about working on those 2 on your own. You're welcome to look at them, But that's something that I want you to be prepared to work on in class with a partner, and that way I can go around and kind of be giving people feedback so that we can get a really good product produced the very first time instead of having to go back and forth to see what we want. And then we'll be all done looking at all of these design things. Okay, so let's open our OneNote notebooks. Get those open. I'll open mine that I created the other day. And I had just created a couple of tabs. Remember looking at chapter 1, put some stuff in there. Yours might not have that stuff, that's okay. Can you find it, first of all? That's the big thing. So we can find their OneNote. Remember I said, getting them saved is the hardest part. And then finding them with this. Throw stuff at you now. Still might go to office.com and log in, but it might not save and change it. It can be kind of glitchy like that. All right, so whatever you have in here is just fine. If you wanted to create a tab for chapter 2 and the binary things that we talked about, the ASCII code table, remember the Unicode code table? All of those things that we were looking at last week just help us internally to understand why we have to tell the software what type of data we're working with, right? Because if I'm working with a string, the operating system is going to do a decimal conversion looking at that code table. If I'm working with an integer, the operating system is going to do that conversion from binary to a number. So that helps the system know how to interpret the data that we're looking at. Great, so let's get started with chapter 3. I'm going to create a new tab, and I'm going to call this the chapter 3 PowerPoint. And I'm going to copy in this whole PowerPoint from the textbook. And this is one of the only chapters we'll use the textbook PowerPoint for, but it's not too bad. So how can I do that? I'm going to find it. Here it is, the first thing in the week 3 module. And then I'm going to download it. Now I'm using Chrome. So of course how things work with the browser you're using might be a little different. But I found with Chrome, I can just grab this button here that says the file was downloaded and drag that and drop it onto my OneNote notebook. And then I can say I want to insert it as a printout. Now if the browser that you're using won't support that, you might have to find the file in your download folder and drag and drop it onto the OneNote notebook. Or you could just do a file import in OneNote. So there's about 1 billion different ways to do it. But however you do it, we want to attach it as a printout. And when you attach it as a printout, then we're going to end up with a page for every slide in the PowerPoint in our OneNote notebook. So let's see how long it takes. Kind of a big PowerPoint. There's going to be parts of it you don't need. You're like, why do we have to copy this whole darn thing in? Sometimes I think OneNote takes longer with all of us doing it at the same time, but I don't know if that's true or not. Probably not. You guys all did so good at making it here. It's like in the teens out there, I thought we would have a lot of people gone this morning. Get everybody being so good. No frozen over cars or anything. Tomorrow or tonight? Tomorrow.
Today the ice still 30.
I thought it wasn't as cold as they were saying. It's cold. They were talking on the news about those people in Minnesota and South Dakota and stuff that have to plug in their cars and, you know, they're worried about pipes freezing. And so I can understand keeping your pipes freezing or thawed out in the house, but at some point they start freezing out in the city. And so everybody keeping it open keeps the city pipes from freezing too, I guess. Keeping it just a little bit going. It's so cold. Yes, sir. What's it doing to you? Fighting back.
So that's the same thing you turn on.
You guys, you can also log into Office from Canvas. There's an Office 365 link. So I think that any way you log in, it gets you authenticated, and then you're able to do things. It's definitely not consistent, though. Okay, now you've got this here in OneNote. As we go through, you can look at each page if you like and make specific notes to the side. Again, remember, you could use the drawing menu if you wanted to highlight things or draw pictures or things like that that helped you to clarify. Remember, in OneNote, I pushed the pin here. So I bring the menu up and I use the push pin to keep the menus active so that they wouldn't roll up and auto hide like that. If you have a small screen, like a tablet, then you want those menus to auto hide. But a big screen, kind of nice to have them just stay open all the time. All right, so let's look at this thing. We are talking about designing a program. We got everything situated here. Now I'm going to actually open this thing as a PowerPoint. Is it working? No? No.
Then YouTube is anything.
But if you do it, you beat it into submission. It's hard sometimes to get logged on. Oh, yours is just taking forever. What is it? It takes it a while with those big ones. All right, if it doesn't do it, you can put it in there later. So developing a program, this is what we want to do. Sometimes when people get hired for their first job, they are ready to write their first program. You know, they jump in, they're all excited, ready to go, and they find out that actually for their position, they're going to change some programs that have already been written. So that happens a lot. And that's because it's all a cycle. We have very few spots anymore where we can start from an absolute beginning, right? It's that way with textbooks too. If you've ever looked at a Microsoft textbook, you'll see it always starts out with what's changed. So it always acts like you have prior knowledge, even if you don't, because it's hard for us to start at the beginning. We already have a lot of things developed. So we have this development cycle. And they talked about it in chapter 1. Whenever we're solving a problem, we need to take certain steps. We need to use problem-solving principles and make sure we completely understand the problem. We have a plan to solve it. We can carry out the plan and review the results. Then when we're writing a program, we have to use some of those same problem-solving principles. We're going to analyze the problem, design the program, code the program, and test it. I am a technology person. You guys probably are too. I have a friend who is not so much. And he likes to kid me that anytime I look at solving a problem, I always think of a way to solve it by writing a program or doing some sort of software-related thing. He says, you know, that's not the solution to every problem. I'm like, I don't know. It seems like it is. It works really well. And he says, you're like that person who has a hammer, and they're just walking around with their hammer, and anything you ask them, you know, if they can fix it, they're like, sure, and just beat on it with their hammer. Just because you have a hammer doesn't mean that's the best tool to solve every problem. And he would kid me about it, saying a software program is not necessarily the best tool. We don't need to throw technology at everything. But we've been doing it that way for a long time. We can get into trouble, though, when we're analyzing a problem, if we get in that mindset that this thing that I like is going to be the way to solve the problem, right? Have you ever seen people do that? Like, even if you're in a group in class, you have one person who has this certain idea, and then they won't listen to anybody else. They won't listen to any other input. You can't get anything done because they're just so stuck in that certain place. We have to be really careful to not let that happen. We want to make sure we're looking at all of the different criteria that are going into this problem. What's wrong with it? What can we do? In Springfield, you guys know that driving in Springfield is really bad, right? Springfield is one of the worst places to drive in the country. We moved back to Springfield years ago from a big city, and when we moved back, our car insurance was more than it had been before. And I said, what's the deal? We moved from this great big city where cars got stolen all the time. It was a lot worse than Springfield then. And the insurance guy said, yeah, Springfield has the highest car insurance rates in the country, period, because we have the worst drivers. And according to all the actuarial analyses that all the insurance companies run, we're the worst, you know? But it's not just the drivers, right? Some of it is because of the roads. Some of it is because our stoplights may not be synchronized in a good fashion to allow traffic to flow. Some of it is because we might have only a one-lane road where 2 lanes are needed because the traffic is increased, right? So we can't look at that problem and say, Springfield traffic is bad, Springfield drivers are bad because drivers are idiots. No, that's not the only problem, right? That might be part of it, but this has many, many different pieces. And that's what we always want to be thinking about. What are all the different pieces? Because if we walk in to help somebody writing a piece of software, we want to make sure that we're really understanding their need so that we can design a good program. Now, if we were looking at games, creating games, it would be the same kind of thing, right? We want to know what kind of action we want. What kind of problems we want the player to be solving. What kinds of things are going to be happening, and so that we can design a good solution. So no matter what kind of application we're talking about, we have to follow these same steps. So let's analyze the problem. Have you ever played the lottery? They have a lottery example here, so it's important if you've ever played. With a lottery ticket, like the scratchy ones, they have different numbers across the top, like maybe 5, maybe 3, whatever. Maybe numbers that you're supposed to pick, like I think Powerball is that way. So if they have 5 numbers, they have specific rules. Like these numbers are going to be between 1 and 50 or between 1 and 200. And they have rules about, do they allow a number to repeat? You know, can we have the same number more than once? And in our text, they want you to think about that because we want to think about the input we need to produce our desired output. So if we want to create a lottery ticket and we just have some sort of generator, if we generated something like this first one of all 7s, would that be okay? No, right? Because if we said that we couldn't have duplicate numbers, that wouldn't meet our needs at all. But if we said that we could, then maybe it would. But in general, we say the rules are that we can't. What about this next one? -3, 0, 8, 9. Would that be a good lottery ticket set of numbers? Yeah, we probably don't want -3. What else? There's a few problems with that set. Yeah, we have a duplicate. Do you think 689 is a little large? Yeah. That would be kind of hard to ever guess the right one too. So we have a lot of issues with this one. Range violations. We probably don't want 0. We don't want negative numbers. We don't want anything that big. We have duplicate violations. So a lot of different problems. The next one, we have 1, 2, 6, 47.98765, 88, 93.45. What do you think about that one? That'd be a pretty impossible one to win, wouldn't it? So again, we don't want decimal numbers, floating point numbers. We only want integers because that's the only thing that makes sense. Again, some of these numbers might be a little too high also, depends on our range. So for all of those things, we got to be more specific. So even though we can start out saying we want to generate 6 numbers for a lottery ticket, we can see just from these few little samples that we could come up with all sorts of stuff if we didn't have more specific rules for what's needed. So we need to make sure that our problem analysis is pretty thorough and that we know and understand exactly what is required. Once we do that, we can design the program. So if we design it, we're trying to create a description of it that we can share with others, right? So it might be pseudocode. We've seen that. But there are other tools that we can use to kind of describe this design. And that's what we're going to look at in this chapter. Some charts and models. So no matter what tool we're using, we're going to be trying to identify the algorithms. First do this, next do this, next do this, so that we can make sure and complete our task. So we have to make sure that we do everything in the right order and we take all of the correct steps. So when we're declaring these algorithms or designing them, we want to make sure that they're really well defined. We know exactly what's needed. They're well ordered. We don't have things out of order. If you've ever cooked, you know how bad it can be if you try to read through a recipe that's not in the right order. In some of the ones that are online right now, you can really have a hard time following because they're so worried about trying to stretch it out to display a bunch of ads and things like that, that you might not get steps in the right order. So it might talk first about the ingredients you want. You can click some button to generate this order to Walmart right now to order everything you need, right? But you can't find what you actually do with those ingredients unless you scroll and scroll and scroll and scroll and scroll. So that's an ordering issue, right? We can find everything, but it's not very well ordered. It's really hard to locate and things aren't necessarily in the correct order. Oh, those last two are important. I skipped them. Must produce some results and must terminate in a finite time. You guys are doing Scratch. One time I had a student do a Scratch sort of video type thing. I don't know what it was. It was like the beginning of time. And it took about 45 minutes of my time. And I told him, we didn't get along super great after that, but I told him, this is not the kind of result, you know, that we're looking for an assignment where I had said no more than 3 minutes to give me 45 minutes of the dawning of time. So it was a great, you know, huge production and he spent a lot of time with it, but it was not the desired results. It was some results, but it did not terminate in a finite time. It used an inappropriate amount of time. Plus he spent too much time on it, right? So we have to be careful with things like that. We can lose a lot of our time just going off on tangents. Sometimes we learn a lot, but sometimes we don't. So we got to be careful. So we want to code our program after we've designed it. This is the step we're always looking for. As programmers, that's our hammer. We're walking around saying, let me write some code, let me write some code. I have this, I'm ready, I can solve your problems. Well, once we're ready, we can actually write that code. as we're writing our code, we're going to be creating some additional documentation along with all those charts and pseudocode things, and we're getting this giant book, and here it is, we're supposed to be creating a computer program, and everything's all too huge. We're going to add more to it. We're going to create internal documentation by putting comments in our code to make sure that programmers that come along after us can follow along. And then we're going to create external documentation like users guides or help systems, so that if somebody clicks on our help menu, they have information about how to use the application. So depending on what kind of environment we're working in, that might be a little bit different. If we're creating a mobile app, you know, our documentation when somebody taps on an icon might look a little different than if we're creating a Windows app. But in general, we're going to try to convey the information about how to use it. That'll be our external documentation. When we're coding, every programming language uses its specific syntax. And you guys know that. You've been around, you've heard people mention different programming languages. One thing I want to kind of caution you about, don't get into that rut of picking your favorite programming language. As a software developer, you want to be open to a job. So if they want to use a programming language that you don't think is your favorite, maybe it should become your favorite. Maybe that's the one you're going to love from now on if they're paying you enough. So remember that. We're not in it trying to say, well, I like Python because it's better than C# because this, and this. We all have our favorites. We all have things we like about one and things we like about another. But when we're coming to looking at jobs, we love them all, right? Because they all have their own syntax and we get to solve problems using them. So it doesn't matter which language we use. So here's some syntax. It's kind of like if you were trying to talk to your friend. Let's see, this is German. I have a good German story I have to tell you guys. So when my daughter moved up to Springfield, she went to Missouri State, and she lived in the dorm, you know, for a couple of years. When they finally got their own house, they were just right off campus, and her friends were moving in, and her friend's mom came to help her best friend from Carthage, and I came up, you know, and we were all trying to get everybody situated and everything. And nothing bad about those guys that walk around to tell you about things, you know, like these were a couple guys were, I think, Mormon. And so they had their suits on and they were coming down the road heading that direction. And my daughter's friend was really worried about it. She's a very nice person. And she doesn't want to say no to anybody or turn anybody away. But they have about 1 million things to do because they're trying to get moved in. So she just was really worried about these guys coming up and having to be rude to them because she worries about it so much. And so she kept looking and she kept looking, and finally she says, Mom, go to the door, answer the door, tell them you don't speak English. And so my daughter's friend, Paloma's mom, went to the door, and she answered the door, and they were standing there in their suits and being all nice, and Paloma's mom goes, no hable English. And the guys look at her and go, Español, and they just start speaking in Spanish, so she didn't get out of it anyways. And she still had to talk for 10 or 15 minutes because if you know anybody who speaks Spanish as their primary language, you know that they have to visit with somebody who stops by the door that can't be rude. It's just a thing. So my daughter laughed about it, and she said, you guys, we should have said, sprechen Sie Deutsch, or whatever you say for do you speak German. Now, those guys probably spoke German too, and it wouldn't have mattered because nobody really sprechen Sie Deutsch, but she knew how to say that. So we can have all of these different languages going. What are those new things now? They're saying that the Google can translate.
Like the Google version of AirPods.
It's the AirPods. So you're just listening and it automatically can translate from one language to another for you. So
there's a lot of devices like that nowadays.
It'll just do it on the fly. So pretty amazing. Now you're going to see that there's actually computer programs that'll do that same kind of thing, like convert from one programming language to another, you know, try to change that syntax for you. But that's really what we're talking about here with these different languages. Is the same as the different languages that are spoken. So if we are telling a friend, you put a cheese sandwich on the table, you would say, I've put it on the table. You would not say, I have it on the table put. But here they say, if those words were converted to German, that would be the correct order for the German syntax. So it would have a different order of words. So we have to be aware that the syntax that's required by the programming language we're using is pretty specific. And we want to make sure that we're following those rules. Finally, we'll be ready to test our program. We'll be testing it as we code it too. But once it's done coding, we're going to be doing the thorough testing. So as we go through and test it, we're going to be asking questions of ourselves, and our users are going to be asking questions. Did everything interpret the data correctly? Did it handle it? Does the program do what it's supposed to? Are the formulas and everything correct? Is it handling it all right? So we want to be making sure that everything's working properly, but not only just working. It's not going to just be that it runs. It's going to be that it gives us the right results. Based on the input, we get the right output, all that kind of stuff. When we're in the design phase, we're going to be desk checking. That's what we have to do with our pseudocode. All we can do is look at it and say, yep, it looks good. Does it look good to you? Have someone else check it for us. Yep, everything looks good. In the coding phase, our software development environment will alert us to syntax errors, but it won't tell us if we have trouble with our logic, something isn't quite right. So we have to test our program with lots and lots of different data sets to make sure that our logic is correct, that we always get the right output based on what we're looking for. Now, when we get done testing, we still have a few things to do to wrap everything up. We have to create an outline of the program. If we are doing documentation like this, we might be required to describe how each of the tasks is carried out in our program. We might need to create a user's guide if we're selling our software, create those help files, train employees to provide telephone or web-based customer support. We might have to create like some flash drives or something to send out for distribution. That might be part of our responsibility as the developer. We wouldn't think it is, but we might need to do that for our company depending on how small we are. We might need to advertise the program to attract buyers. One company that all this makes me think of is Jack Henry. You guys are familiar with Jack Henry, that's got a lot of offices here in Springfield. Their headquarters are in Monette, like about 30 miles away. And so Monette, so gosh, when Jack Henry started out there in the 80s, it was a very, very small town, still a very small, very rural area. And they make banking software, right? So they make software that's got to have a lot of security requirements. You can't just have anybody messing with it and things like that. So over the years, they've hired more and more people to provide phone support. So that's one of the things they do. I think of that great big giant brick building out on 65 and Battlefield is some of their phone support people. That's a really great job for entry-level computer programmers, right, at Jack Henry. So be watching, watch their website. They're always hiring people to do phone support. Now, it can be kind of a dry job at first, right? But oh my goodness, it's helping you so much because you're going to learn about their systems and how to deal with customers and how to talk to the customers on the phone and how to handle all of those kinds of things. Now, when Jack Henry first started, they say way back in the 80s, their developers, like their owners, would take floppy disks with all of their software to the banks where they were going to install, and they did all that early stuff on their own because they didn't have a big staff. Well, now looking at some of the buildings they have around town, they have a really big staff. And they have plenty of people to take care of, sending out flash drives to all their banking customers and things like that. But they still have to be concerned about it, right? Because I use UMB. I know there's a bunch of different banks. UMB always surprises me because they do their own software development like out of Kansas City. So they have their own developers that create their mobile app, that do everything. They don't use Jack Henry software. Most banks the size of UMB would probably use Jack Henry software. So they're sort of a mid-range size bank that buys it. So they supply all that stuff. So a really cool place.
Oh, another thing with the phone jobs, people in the cyber departments like developers that go in knowing their frontline systems.
So just having had that experience.
Yeah, like at T-Mobile, I would have a better chance of getting hired over somebody else at headquarters. I know the frontline systems and I work with them every day.
Yeah, anytime you can get familiar with the company, it's going to help. So that's a great place. We have a lot of good employers in town. Jack Henry is definitely one of them. Good. I just zoomed in. That's not right. Let me click over here then. So everything is a process. It's cyclical. It can require months, years, whatever. As we work through our design process, we might find problems, things that are bad. We might have to back up and redo because we found a flaw. As we're coding, we might run into things that are problems. We can't do this in this language, you guys. I don't know what these design people were thinking, but we're not going to be able to do it that way. You know, so we might have to back up a little bit there. And then in our testing, we might also run into additional problems that require us to back up and a little bit of redo. Now, you guys know every time we back up and redo, that's going to be more expensive than it would have been to have done it right in the first place. So over the years, as software developers, we've gotten to the point where we really like design, making sure that things are going to work right before we do it. So sometimes we don't have that luxury, but other times we like it. Okay, here's an example program. Take a look at it. This program, in our pseudocode here, is set to help a department store. They want to be able to input an item's original price and the percentage it's discounted. So like if I go to the store and it says this is $19.95, if there's a sign up that says it's 20% off, they want us to be able to type in those two things. It's $19.95, it's 20 is my percentage off. Then this program is going to calculate the sale price of it on sale and the sales tax that goes along with it. So we have some information here. We have the output required, the input required, and the formulas required. So this isn't really pseudocode, is it? It's got a lot of the components of a pseudocode. It's pretty close to it, but it's not quite. It's more just an overview, like a design document that specifies kind of an overview. So let's see what's next. So we have another way we could express this information. This is an IPO chart, input, processing, output. So in this IPO chart, we start out by creating 3 columns. And we have one column where we're going to list all of our inputs to this program. One column where we're going to list all of the processes, and one where we're going to list the output. So this is often referred to as the data processing model, because data processing was really old, or the software development model, IPO, input, processing, output. Now in our textbook in chapter 1, remember they get off a little bit about data, but we've already got our data covered here because it's input or it's output, right? So these are our 3 things that matter: input, processing, output. So in this chart, it's a nice overview for me to look at. I see that I need input from the user for the name of the item, the original price, and what the percentage is that it's discounted. And my output that I want to display when we're all done is the total price. I want to redisplay that name again, the tax amount, and the sale price. And then here in the middle, we have all of the calculations documented for us. So they often say that whenever you're going to be a software developer, you have to have mad math skills. And you do if you're going to write games and you're going to calculate the physics and trajectory of the blood spatter pattern, right? But for this program, we don't need big math skills because the user said, this is the math you use to calculate these formulas. And this is the way it is a lot of times. Your accountants or actuarial people are going to tell you what the formula is. So a lot of times you don't have to be the math whiz. Just sometimes if you're working with really graphical things like that. Okay, so this is an IPO chart. You've got it in your notes? Make sure, because it's one of those ones that's going to be really, really handy. Sometimes it's just nice to have a real simple way to get everything down where we can see it. So whenever we're designing a program, we want to get down those things like the tasks that are important. We're going to go back to that sale price program, don't worry. But we want to make sure that we know the major tasks, like that sale price program needs to calculate the sale price, right? And then when we're looking at our major tasks, we might want to split those up to be a program module. So we can split things up to make it where it's easier for multiple programmers to work on the same program. We'll look at that a little bit more next time. Let's see where we are here. That's what I want. So we're going to talk about those modules. But before we do that, let's take off here and let's look at some of the other stuff that we need to know about. So we're going to stop with our Chapter 3 PowerPoint right there. And you want to keep your notes open because we're going to look at Microsoft Imagine and get in your free software. Now, right now, they are in the process of renaming Microsoft Imagine. So you guys might have emails that I don't know how to find. So we're going to try to figure out how to get everybody logged on here to the Imagine website. So the first thing I want to do is see if somebody else will take over this share so that we can show all the other students how to find all their stuff. So I'm going to stop sharing. And I need a sharer. Let's see what we got here. Go to your email for me, your OTC email. Where are you? See it. The only problem with you guys sharing is I can't. There it is. So my problem is it's got you on the opposite window. View options. Here he is. Okay. Okay. Now I've got him on the big screen too. So in week 3, one of the info modules is this Microsoft Imagine free software. He's got it. So this link here will take you to our web store. Now, things are changing, like I said. So we'll figure out as we go here if something's changed. We need to sign in. And normally you guys get an email saying that this account has been created for you with a link to get you signed in. So let's go to your OTC email. Let's see if we can find the email. Now it used to say an account has been created for you, and it would always go to everybody's junk mail folder, making it really hard to find. No junk email. So let's search for, oh, there you go. Is that new? Yep, it is. Perfect. Okay, if you can see, Chad, go back to that search if you would. So he searched for Imagine and he found the email. And it says your school created a Microsoft Imagine web store account for you. So now you guys realize things are changing. Microsoft never likes to leave things alone for too long. So we're going to get logged on to this. The next time you go to use it, it might be different. So let's create your account. Click there to complete your registration. Now, this is not anything that you have to do. This is all the benefits for you. So this is just free software for you from Microsoft. So set up your password and your name. This is an agreement that you're creating with Microsoft. that you will use this software for your educational purposes. Whenever you download and install free software from your Imagine account, you can use it for school and for you, but you're not supposed to use that software to make money, right? It's only for educational reasons. So once you start making money with Microsoft software, they want you to buy it instead of using it for free. Now, most of the software that you get from the web store here, you can install multiple times. So most of them allow you to install like 3 to 5 times. So if you've got your account created, everybody good? Account created, click Start Shopping. And let's take a look, first of all, at what all you can get. Now, one thing that you can get is Windows. So let's search for Windows 10. There it is. It's right there at the top. Didn't even have to search, did we? Click on that. Now, if you were going to get a new PC, someone said it yesterday in one of the other classes. He was like, oh, no, I just got a new computer, and I could have, like, saved $100 or something by checking that I didn't want an operating system. That's true. You can get Windows 10 for free. And the thing is about getting Windows, make sure you know how to install it before you start messing up your computer, right? Because you're talking about the operating system. So if you don't know what you're doing, take it over to the OTC PC repair people, and they will install it for you for like $40 with your free software. So don't do it yourself if you don't know how. If you know how to. But say you know how and everything's good and you're ready. We're going to go ahead and add it to our cart, just like any other store. And then when Chad adds it to the cart, look, it's even making recommendations for him, like other software. Gosh, it's like you're on Amazon. That's a new feature. So you can look at that Visual Studio. You're going to need that when you take the C# class, but for right now, you probably don't. So he could uncheck that, and then he could, is it okay to check out? I don't want to mess you up. Let's go ahead and check out. And what's going to happen then is Chad now can download this software, and it's going to even give him instructions on how to burn it to a DVD or something like that. Really, now you'd want to download it, put it on a flash drive to install from. What's important here is in red, the product key. If he installs this Windows 10 installation, he must activate the software using that product key, or else he'll just be running a trial, and after like 60 or 90 days, it'll expire. So always make sure that you activate your software with a product key if there's one available. So now you don't have to do anything with it, but it's ready for you to download. So let's go back and look at the store again, the main store. And the piece of software that we might want is Microsoft Visio, V-I-S-I-O. Now, Microsoft Visio is a drawing tool. So and I'm going to show you here in a few minutes how to use it a little bit. It lets us draw things like charts and flowcharts and diagrams and things that we like to use in software design. So it's a nice product. Software developers, engineers, different people like that have different kind of drawing needs at work use Visio, so we have the option to use it. Now, if you wanted to install it at home, you would just add it to your cart, and then when you check out, you could download it. Because it is just a piece of software, it'll install fairly easily, painlessly, and you'll be good to go. Now, we'll only do one assignment in class where you have to have a Visio flowchart to turn in. So you really don't need to install this at home. But you might want to use it for other classes. You might want to use it when you get to the more advanced programming classes, or you might just want to use it, so that's up to you, but you don't have to. Okay, so basically all of the Microsoft Imagine stuff is out there available to you just if you want it. So there's not going to be anything in our class that says you have to use any of it. So when you take C#, you're going to want Visual Studio. We have all of the SQL Server tools for when you take the SQL Server course. When you're looking at the free software available from Microsoft, you're going to see everything. Windows Server. So if you were always wanting to create your own Windows Server so you can set up a Minecraft server on Windows or something, you have all of the capabilities to do that. So everything you could ever need. Let's take a look at the whole list. Look at Microsoft Imagine. And then as you scroll down, see if you see anything interesting. We're just, is it sorted? It's kind of a new look for the display. So there's some older versions of Visual Studio that you could get if you wanted. Some of the Office products like Project and Access, those are the pieces that are not available within the standard Office installs that you guys can get here. Some other pieces of software. So things have changed a little bit. Look around, get used to it. If you notice those tabs up at the top, besides Microsoft software, what's on VMware? Do we have anything there? VMware Fusion 8 for Mac. Oh my gosh, that's awesome. So this is not something that's ever been available before, but this means that if you have a Mac, you can download VMware's Fusion, which is allows you to run Windows on your Mac, and you can toggle back and forth between your iOS and your others. It still costs money though. Darn. I was hoping it was free. But at least it's out there, I guess, a good easy link for you. So all those links at the top are new. What about Adobe? Are they going to give you anything free? Adobe hates to give away free stuff. Is it heavily? 20 bucks a month?
$30 less.
Is it really 50 bucks a month if you're just a person? And people pay that? That's intense. Because you've got to have a good business doing that. So this is kind of cool. They're pulling together all these different software manufacturers. That's new. So that's why I'm kind of just looking at it going, well, interesting. I didn't even know that that was something that was available. So you might find all sorts of great things out there. There's parallels for your Mac also. So see if it's free. You can do some looking around. $40. So I guess it's cheaper than the VMware Fusion. I don't think it works quite as well either, but at least it's a little cheaper. So depending on what you've got on your Mac. Awesome. Let's close it. You can look around through the Imagine web store a lot. And if I say Microsoft Imagine and you're seeing some other name, let me know and I'll try to update. It started out as Dream Spark. And so it just keeps going through all these different evolutions of things. My son works at OU and he's in the meteorology department. And so he has a subscription to Microsoft Imagine for the students in that department. The subscriptions cost about $300 a year and give all of you guys access to all the software. And he's having a little bit of a meltdown because the IT department for the entire university has come in and said, no, he has to buy all of these different pieces of software for his lab computers. So he said it would be like $200,000 or something instead of that $300. So we'll see, but it'll save you a lot. So take advantage of it. Okay, let's close that one.
So if we wanted to get back to it, do we just go back to the email link?
That's a good way to get to it. One thing, excuse me, that I found is if you Google OTC on the hub or Ozarks on the hub, it'll find the right web store. One thing to be aware of, though, that I didn't mention that I should have is you can't just go to any, Microsoft Imagine web store. Every school, every university around has one. And so you have to make sure it's Ozarks Technical Community College, Computer Information Science for you to be able to log in, or else it'll be somebody else's at some other university and you won't have an account. So it'll look just the same. Awesome, thank you guys. Okay, he's gonna close and I'm gonna steal that back. Thank you, child. Okay, so I think I'm sharing. That's what I want. I have to get a different OneNote notebook open here for a second. So we're going to look at flowcharts. And some of you might have seen flowcharts a lot. Here's one. This flowchart is talking about the weather and checking the weather. So right here, notice that it has special symbols to indicate the start and the stop of the flowchart. That's good. That helps us to know exactly that we're seeing the whole thing, that nothing's missing, that we know where the beginning is and where the end is. Okay? So that's helpful to us. Those are called terminators, right? Because they terminate both ends of the flowchart. So that's a nice thing to do, give that to people. And then if we look at this flowchart, we can kind of read through it, right? We know how to follow it. It's sort of a thing that we've been taught. We know the first thing we're going to do here is check the weather channel. Over here they have a comment, an annotation, and they say the weather channel is on cable channel 61. Oh, that's helpful. I don't know what ours is. I'm sure it's not. And then there are some arrows here on the lines telling us which direction to go to follow this flowchart, because otherwise things can get a little crazy. So we're going to check the weather channel. Then we're going to make a decision. Is rain predicted? Is this true? If yes, we're going to follow this path that says yes, and we're going to decide to stay home. That's the end of our flowchart. If there is no rain predicted, they're going to play golf. I might do something else. That's okay. Play golf is what we're going to do. And then that would be the end of our flowchart. So in this flowchart, we're just making a real simple decision, right? If rain's predicted, we're going to stay home. If not, we're going to go play golf. So everything's pretty easy, but it's a great flowchart because look, it has some examples for us. First of all, it shows that each box, each symbol, so we have one thing. Right? I shouldn't have a whole bunch of stuff stuck in one. Secondly, it shows that just a process is a rectangle type symbol. And if I make a decision, I should use a diamond symbol. And I should have two lines coming out of it. One for the true path, one for the false path, or yes and no. So it does a really good job as a really small flowchart of showing us some good examples. One other thing that's kind of cool about it is it has this line that shows that if we stay home, we bypass this, right? We don't affect that at all. So it's got a lot of great things in it. It's some great features. Good flowchart. But what about this one? Let's take a look at it. This is another flowchart. Now, right away, notice that it uses some of the same symbols, but it doesn't have those terminator characters, right? So right away, we wonder, are we just seeing the middle of something? You know, is this just been pulled out of some other flowchart? Because we're not really sure we're seeing the whole thing. So the start and end is really actually very helpful, even though in our mind, we might be absolutely sure where it is. We want to convey that. And then this flowchart starts out with a decision. Do you have homework? No, you are lying. Yes. So no matter how you answer that, it goes right back to the same place, right? Is it due in less than 12 hours? Yes, you better start working. I think that some of my students wait until an hour. That's what I see. And then if it's not, we're saying if it's not due in less than 12 hours, you have time to watch some TV, maybe play some games, check everybody on Facebook or whatever, and then check again. Is it due now in less than 12 hours? So this flowchart shows some looping. So I like that because it's saying we're just going to keep doing this over and over and over until it finally gets to close enough that our motivation sets in and we can get everything done. Now, one other thing with this flowchart, notice over here where they said start working, they use that terminator symbol. That was wrong. So it kind of gives us some bad cues, but it still gets the message across, right? We get the idea. It does it in a graphical way so that somebody who doesn't like to do a lot of reading or, you know, words kind of melt on them or whatever, they can still get the idea. So we can display things in a nice graphical manner and convey what's going on. Now here's a messy flowchart. This one shows a little bit about why we want to make sure we follow the flowchart rules. So it said, did you ever even study They use the wrong symbol, right? It's not a decision at all. And it only has one path coming out of it. So why are they even asking, right? It's totally irrelevant. They don't care what you say. They're going to go right into this next question anyways. Is rest your major? Well, now we got all sorts of things going everywhere. No, but yeah, sort of. So we can see that the whole thing is just a giant mess. And it's really hard to follow. And it looks totally like nobody would ever do this, right? Wrong. Seems to do this. So we have to be really careful as how we lay things out. We can't have lines crossing other lines unless it's absolutely necessary. Make sure that it's all clear. This one, some people have seen some. I like this because it reminds me of the messy flowchart. Have you guys ever seen these? They went out as emails years ago. It's kind of spam. But they went out saying, do you know where this is? These wires. You can see, you can kind of get an idea of where it is. So it used to go out as an email chain or whatever, and it would always end with, this is where our tech support calls go, which is true, because this is India. And in India, they don't have standards for cable management, right? Because, yeah, isn't it? Really crazy. So I guess what's really crazy is, like, you see this one coming up here? I don't know, it's kind of like sticking out right there. Apparently people come out in the night and try to hook up to power, you know, and they'll try to plug in, and if it doesn't go well, you know, they might be out there the next morning still. So there's no standards, everything's crazy. I think that things are probably a little bit better in India right now because I think that they've fixed some of these infrastructure problems. But this is why we have to have standards, and why, you know, if my dad came to your house back 20 years ago to fix your phone, he would have to follow very specific rules on how to run that cable and make sure everything was done exactly right. This is the kind of stuff we come up with code if we don't design what we're doing. We don't think about how we're going to create this program, and we don't do any planning. That's what we end up with, spaghetti code, right? It's bad. We don't want it. We want everything to be nicely laid out and planned. So we always want to make sure that we're doing things in a nice, logical way. So let's write some pseudocode for that sale price program, and then we'll look at, well, let's do a flowchart for it. That's what we want to do. So I've got the sale price program. Let me bring up that pseudocode that they showed us in the PowerPoint. I think that was the best one. Oh, I'm finding it. Okay, so it wasn't exactly pseudocode. It was sort of, like I said, just some words. And then right here, we had the IPO chart that gives us a little bit more information. So these are on slide 10 and 11 of the PowerPoint. So we could create a flowchart first, or we could create pseudocode first. There really isn't any sort of required order. So let's create our pseudocode first, since we've done that already, at least once, and we can get an idea of what we're doing, and then we'll create a flowchart that matches it. So we used Notepad++ to create our pseudocode. And I have a bunch of stuff open that I'll get closed here. So the only thing that you should have, if you do have, Notepad++ might be opening up with our music pseudocode that we created for our music purchase program. So let's create a new file. I'm going to choose File, New. Now, Notepad++ just creates a new tab and calls it New One. So let's save it. Notice we have to choose Save As. And mine popped right up in the location in the folder where I'd created that music pseudocode. So that's good. I want to save things there. Now I'm going to name this one just a little bit differently. I'm going to put CH3 in front of it so that as we create things, they'll sort properly. And this is going to be our chapter 3 sale price pseudo. And you can put a lot more information in that name if you like, but I think that's probably long enough. Now, before we create our pseudocode, we want to put some comments. And we're going to say this is going to be the sale price calculator. And I'll just put a nice from there to say it's from our Prelude to Programming book. And finally, our purpose is going to be to calculate the sale price of an item. Whenever we were looking at our first chapter in creating that very first pseudocode, we saw that our textbook likes us to use the keyword declare, say that we need a variable. So we need to declare our input variables. I'm looking at this IPO chart. So I'm going to declare, first of all, our item name. Now, when we create our pseudocode, our textbook said we should use the keyword declare, followed by your variable name, then this keyword as, and then a data type. So what kind of data type would we want to use for item name? String. Perfect. And then the next input variable we need is the discount rate. What kind of variable should it be? Now, with this discount rate, qualified, we're going to be asking them for the number, like 10%, 20%. So what kind of data type do you think would be best? Well, this one is just going to be the rate, so we're not going to be carrying a decimal. So you're absolutely right. For this one, we're going to use integer, and we'll use float for our answer, because we don't want to use extra space if we don't need to, but we might not actually do it this way in the real world. We're just getting started here. Now, the next thing that we need is the original price. Now here, what do we need? Here we might have a decimal, right, in the price. So we better make it a float. Now I could, if I wanted to, even put a comment that says, first I have my input variables. These are the variables that we're going to be asking the user for. And then we could have our other variables. We have some outputs. And we don't need to organize this way, but if it helps us keep our thoughts clear on what we have, then it's going to help other people that come along and use this program later. So for our outputs, we're going to have the total price. What data type should that be? Float. And we're going to have our item name again. I don't need to declare it again. We're going to have our tax. That would be a float, because that could be a number that ends up with a decimal place. And lastly, our sale price, again, is float. So most of our outputs, if you notice, are going to carry a decimal. Now we have one other variable it looks like we need. So I'm going to put another comment in and say these are going to be our processing variables or calculation variables. And the only one we need is amount saved, and this will be a float. So they want this to be kind of like the amount that is discounted off the price. And so we might see a lot of different variable names for these, but these are good names. We're using camel case. We're starting with an uppercase letter for each new word so that it's kind of noticeable that it's a new word. So it looks great. All right, so now we want to start out in our pseudocode with our asking for input. So we're going to prompt for input. So first we want to write out our prompt. What do you want it to say when we ask them for the item name? So we say enter item name. Does that sound good? Now I put a colon and a space because I want the colon to kind of be like a break. Our brains like things like that. Oh, I need to type after that. And then if we put a space, whatever they type won't be squished right up against our prompt. Now, once we write that out, the system is going to be sitting there waiting for them to type something. When they type something, we want to read that in using this input statement into our item name variable. Then we want to write out a prompt asking them for the original price. And we want to input that data into our original price variable. And when Notepad++ gives you that autofill option like that, you should be able to press Tab or Enter to have it drop that word into your code so that you don't have to keep typing it all. Now the last input we need is going to be for our discount rate. So let's say, I don't know what a good way to say that is, discount percent. And then we'll input that into our discount rate. So remember, if you are having a hard time keeping up, I'm not typing all these letters. I'm using the Notepad++ capabilities to auto-fill some of it so that I don't have to be typing, because I had my typing class a really long time ago. So we don't want to do that in this class. All right, so now we got all our input gathered, right? We got everything all gathered. We're ready. We have all of the data that we need. So let's do some processing. I'm going to go down a few lines so that you can see where I am, and I'm going to put a comment. So we're going to be processing the data to produce our output. Now, they gave us all the calculations in the PowerPoint, right? So amount saved, I'm going to calculate by taking the original price times the discount rate divided by 100. Now, that's a great calculation, but I feel there's a problem with it. Based on the order of operations, which we haven't got to yet, don't worry, we will. What's going to happen first in this calculation?
It's going to divide the discount rate by 100.
First?
Multiply.
It's going to multiply, but that's not what we want to happen, right? We want it to do that division first. So let's put that division within its own set of parentheses. And then we can make that happen first. And we will be talking about that next chapter in a little bit more depth. But for now, we know we just need to get things so that the calculation is correct. Now, after we calculate this amount saved, we can figure out what the sale price is. Now we know what the sale price is going to be the original price minus this amount saved that we just calculated. So let me ask you a question. Does it matter what order I do these 2 lines of code in? It does, right? Because I can't use the amount saved until I've calculated it. So I better keep my code in the right order. Because again, just like making a pizza, I can't put the sauce down unless the crust is there. I want to make sure that I know what the amount saved is before I try to use it. So it does matter what order. Now, the next thing we can do in our calculations is figure out the tax. And we might have been able to do this earlier, but I don't think so because we needed the sale price to calculate the tax. Because we don't like to pay tax on the original price. We only like to pay tax on the sale price. So they say we're going to multiply our sale price times 0.065. That's going to be our tax rate. And then finally, we can calculate our total price is the sale price plus tax. So if you notice, I just took this information directly off the IPO chart. It had all the calculations in it, and I just used them. Now, in the IPO chart, things might not be in the right order, so I have to make sure they are. But for this one, they were. So everything was fine. I could just go directly off of that. And now I want to output. So we want to write out some information. Let's see. We want to say something like, the item name, and I'm going to keep concatenating here, is, and then I'm going to put my discount percent, discount rate. So I'm going to say something like, the item hairbrush is 20 off. That doesn't sound good. I should put a percent sign there. So I'll make it say 20% off. And then we can write out some additional information. The original price. And we'll add that original price. We'll go down another line and say the sale price. Now with our sale price, we could say something about how much they've saved. The sale price, blah, 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 results in a savings of, it's like Kohl's, right? They always tell you how much you saved. And then we could output something about the tax. Now our users are probably going to say exactly what they want output. We don't have that information, so we're doing the best we can. The sale price results in a savings of, 43 cents. So we'll say total due is our total price I think if we said total due is total price, a tax of, now we could format that in a lot of different ways, and you guys see that when you get different receipts, right? That they all format things a little bit differently, so we can get it set up the way our company likes. But I think we've got all of the information being output there. At least somebody would have something to look at to say, oh, I kind of don't like it that way. I would rather we do it this other way. Now, we are in our design mode, so looking at our pseudocode, the only way we could validate it is to desk check it, to make sure that we have all the variables we need, that we're not trying to output something that we didn't actually calculate, that all of that stuff looks right. So we would just look at it, make sure everything looks good, and if we're all set, we can save it. So next time, we're going to take this pseudocode and we'll use Visio to make a flowchart. And then we'll look at Raptor so that you can see how we can use Raptor to actually run this and execute it and make sure that we have it right. But I'd like to stop there. I know sometimes I don't give you as much lab time as we're supposed to, but we have so much to do. So lab time, you've got about 20 minutes. Make sure that your scratch game is all set the way you want it. If yours is all done, spend a few minutes looking at a few other people's. Give them some feedback before you take off. But if you have work that you need to do, get that done now. That's what we'll do in our lab time today. Does anybody have any questions before we do that? All set? Great. Okay, well, yes, sir? Sure. And if you guys want to copy this into your OneNote, over. We brought that up before. I think they fixed it. These silly things. Yeah, that missing. I swear Canvas did that last year and they fixed it, and it must be doing it again. See if I can figure out a way to make it stop.